Yeah, I'll let you guys try those too. Let's take a look at these two. Okay. So number 9, we've got 5x plus 2y equals negative 2. So notice that we're probably going to have to divide by a 2, but 5 is an odd number, so if I multiply by 1 and negative 1, it's not going to end up very nice. So why don't I think about that and think about 2's? If I multiply 5 by 2's, I get 10's. 10's are easy to deal with. Okay? So watch. 5 times negative 2 plus 2y equals negative 2. It's all about making it easier for ourselves. 5 times negative 2 is negative 10. Negative 10, we add it to get it to the other side. Negative 2 plus 10 is positive 8. Divide by 2, and y equals 4. That one was pretty nice, wasn't it? With 0, we already know what 5 times 0 is going to be, right? So 2y equals negative 2, because that eliminates. Divide by 2, y equals negative 1. Okay. Now let's take a look at the positive 2. Okay, 5 times positive 2 plus 2y equals negative 2. 5 times 2 is 10, plus 2y equals negative 2. Subtract 10 this time. Negative 2 minus 10 is negative 12. Divide by 2. Y equals negative 6. Plot those points. 2, negative 6. 0, negative 1. Negative 2, 4. Works like a charm. Good enough, right? Okay, on number 10, same idea. Okay, same idea here. The x and the y, we can make negative 1, 0, and 1. So this is kind of the tricky part. If there's a negative in front of your variable, keep the negative and put whatever you had inside. And I know it looks weird. Okay, so minus a negative actually makes a positive, so it's really like 1 plus y plus 4. I know what 1 and 4 are. They're 5, right? I want to get y by itself, so I get rid of the 5. We get negative 5 equals y. Okay. If we do 0 for x, that'll just get rid of our x. So we subtract 4, we get negative 4 equals y. You can probably guess what the pattern is going to be, right? Adding 1 each time, so negative 3. Let's double check. Erase that. So 0 equals negative 1 plus y plus 4. Negative 1 plus 4, that's like 4 minus 1, it's 3, plus y equals 0, subtract 3, get negative 3 equals y. Easy to plot our points, draw our line, and we are good to go. So that's how tables can be used, and if we wanted to, we could continue these tables in either direction, honestly. There's no reason we have to stop at just 3, but with graphing, usually that's where you stop. So negative 2 and negative 6, right? Negative 3, negative 7. Negative 2, negative 1, as we go up. 2, 3, 4, 0. Okay? So you can continue those tables. Alright, now the last couple, we're dealing with story problems, which can be a bit trickier for a lot of us. Okay? So the trick here is to think about what's going on and think about how we can put it in a table. So we need to figure out what are the two pieces that affect each other. So Ignatius is looking into adding to his Ninja Pony collection. He currently has 273 Ninja Ponies, all different characters, but he would like more. With his allowance, he figures that he can buy 3 every month. Okay? So think about this problem. What is he trying to do? Well, he wants more ponies, Ninja Ponies, right? So, do we know how many he started with? Well, 273. Okay. Do we know he wants to get more, right? Because that's what he wants to do. How is he going to get more? Well, he can buy 3 every month. Okay, that every month buying 3 is kind of key, because that's what's connecting him. What is he buying every month? His Ninja Ponies. When? Every month. So we're connecting months with his Ninja Ponies. I'll just call that NP. So at the beginning, before we started using his allowance to buy it, how many did he have? 273. Okay, then every month, the next month, he's going to buy 3 more. So 276. The next month, he'll buy more. So 279. The next month, he'll buy more. 281. Okay, the next month, he'll buy more. 284. And so on. Right? We're adding 3 each time. Okay, if you wanted to graph that months could be like your x, so call it months. Okay, how do our months grow? 0, 1, 2, 3, 4, and so on. Our Ninja Ponies, we could call that Ninja Ponies, right? Now those are pretty big numbers, aren't they? So on your graph it would depend on how you want it, what do you want it to count by. But you can't really start at 273 and keep going up. So unless you wanted to go really, really far up. So we're kind of just want to maybe count by, I don't know, 50s. 50, 100, 150, 200, 250, 300. Now that wouldn't work either. If we count by hundreds, it's going to be kind of weird. 100, 200, 300, 400, 500, 600, 700, 800, 900, and so on. Well, at 0 months, he was already at... Wait, why was I thinking 700? Why didn't you guys correct me there? My goodness. Sinking up to 700. So 50 would have worked. Okay, because we could have got to 250. So 50, 100, 150, 200, 250, 300, 350. So I could plot the points. 273 would be, somewhere around there. And then at 1 month, a little bit higher, a little bit higher, a little bit higher, and basically your graph would look something like, depending on how many months you went. Okay, with these being the axes, right? Okay. Alright, so 12, the average person spends about 1,200 eating fast food per year. Okay, so what are we connecting? Well, they're spending money when? Per year. So what are we connecting? Years with money spent. Okay, so if you're one person, I guess you'd kind of think about that. So you would start out spending probably no money, right? After that first year, 1,200. After that second year, 1,200 more. We're kind of looking at like total money spent. Because if we just graphed each year, it would be just kind of a straight line. So this is basically what we want to go with. Okay? And then you just graph it the same way. Years here, total money here, and figure out how to get your graph. Okay? I think that should give you guys a pretty good idea of how to do these. Okay? So I want you guys to try 13, 14, and even 15 and 16 on your own. Okay? So I think I gave you guys a pretty good starting point to it. And we'll talk more about these next time. Alright? So, hopefully that helped, and you can get working on those rest and get to it.